Well, it's 12:31. Why don't we go ahead and get back started, huh?
Thank you, John.
Okay, well, this next presentation I was actually involved with a little bit. About a year ago, Courtney Scarborough came into the library and she took a look at the paper versions of the maps we're going to be talking about. And then the folks up in our special research collection said, well, John, used to manage this collection. Why don't you still, well, at the time did manage the collection, go downstairs and see if he's in the collaboratory. So we got to meet and chat. And I had always wanted to go back. The set of maps is, I'm even forgetting how many there are, but they're maps that go all the way from Alaska to Tijuana, skipping the Canadian portions, showing every last kelp grove of the west coast of the United States, made on a surveying voyage. The purpose was to harvest it for potash fertilizer. Now that never really happened. I don't know how much kelp actually got harvested for that purpose, but it wasn't a giant amount. But as COVID started, not as COVID started, but we eventually got to actually starting to work on this. So Courtney Scarborough is, I forget if you're assistant director or co-director of the National Center for Ecological Analysis and Synthesis at UCSB. And Nisha Jagota, who's going to be speaking with her, is a 2020 geography grad. And we were able to put together this project during the lockdown, after we had already sent all the students home and laid off all the student assistants. We were actually able to bring Nisha back onto the payroll, help her buy some groceries, and help Courtney do some science. So this is another one of those examples of where, like Ryan said, why do this in a library? In this case, we held some of the paper materials. Other libraries had already scanned them, and we were able to get a copy of those scans. And then we were able to project manage and coordinate with the research scientist who's actually going to take that 118-year-old data and use it for contemporary analysis of these ecosystems. So with that, I will turn it over to Courtney and Nisha.
Thanks so much, John. Yeah, good to see everybody. Thanks for having us. I'll share our presentation and start getting going. John already kind of gave you some background, but I'll go through that a bit too. So I'm Courtney Scarborough. I am the Deputy Director at NCES, which is the National Center for Ecological Analysis and Synthesis. Deputy Director. And we're part of UCSB, but our research center is actually located downtown here in Santa Barbara. And Nisha Jagota here is my collaborator, and so she'll be doing part of this presentation as well. And let me just get my notes up here. All right, so one more time. So today we are going to tell you about our quest to better understand what kelp forests in California looks like in the past. So this journey of ours has been a bit of a saga. As when we started this project, there was no information available to tell us how much kelp was present in California prior to 1989. And by the end of this journey, we've compiled a geodatabase of kelp forest area coverage and density across the entire US West Coast that dates back to 1912. So our story begins with historical ecology. So we've been working over the past year on a project aimed at characterizing the historical ecology of coastal and marine California. And when we say coastal ecology, we use a definition kind of more from the ecology side of things, and we define it as a transdisciplinary melding of ecology and history, and often with the goal of applying deep historic perspectives to issues of modern conservation and sustainability. So we're using this lens to try and characterize key species and ecosystems in coastal California and be able to track how those species and ecosystems have changed through time. And we want to go as far back as we can. And that's actually pretty far in California. So humans have been utilizing coastal ecosystems in California since people arrived in California over 13,000 years ago. So there's actually this hypothesis called the kelp forest hypothesis, kelp forest highway hypothesis, that humans during the last ice age crossed over from Asia, all along land the entire way, harvesting from kelp ecosystems, because the ecosystems all the way from Asia through the Bering Sea and all the way down to California are really similar. So people could use the same hunting and fishing techniques and kind of harvest almost the same species that entire way. So we call that the kelp forest highway. And shell middens across California have shown that humans have been impacting the size and abundance of different species in the kelp forest, like the abalone you see here, for at least 8,000 years. So central to our understanding of historical ecology of coastal California is understanding these kelp forest dynamics. And, you know, just as terrestrial forests support an immense amount of species, so do these underwater forests. And here's what Charles Darwin had to say about kelp forests back in 1834. He said, "I can only compare these great aquatic forests with the terrestrial ones in the intertropical forests. Yet if in any country a forest was destroyed, I do not believe nearly so many species of animals would perish as would here from the destruction of kelp." So kelp forests are kind of really fundamental to a lot of ecosystems across the world, but especially California. But when we look to the historical record to see if we could find information on all these species, there wasn't really much about kelp, and nothing about how kelp coverage had changed through time before aerial and satellite imagery started, which goes back to only 1989. So we were missing this key puzzle piece as we sought to understand what California's ecosystems looked like. Because we've been able to find quantitative and qualitative descriptions and stories about lots of our species of interest, like the abalone you saw, our sea lions, forage fish, estuaries, but we have little to no quantitative information for this foundational species for the nearshore across California. So we started looking to the primary literature to find records of kelp canopy cover. And it began to feel a little bit fruitless. You'd sort of dig and find references, but they'd be small scale or like just Santa Monica Bay information. But our big breakthrough came when we came across a historical account of a voyage taken in 1912 at the request of the US Department of Agriculture. So they were going to map potash resources and their availability in the form of kelp across the US West Coast. And at this time, these resources were in high demand because they were used for ammunition and fertilizer. And the majority of this was only mined in Germany. So the US was really eager to try and develop some of its own sources. So published in 1915, this report you see here gives a detailed account of the sailing voyage from Baja all the way up through Washington and then into Alaska, as John mentioned. And they mapped the area of each individual kelp bed that they came across to potentially harvest it. And the detailed calculations are really impressive in this report. And when I found this, I was really excited, and I was thinking it'd be a great source to start to be able to kind of calculate what kelp looked like in California, and had a lot of insights to offer what it looked like in 1912. But as you can see here in the very bottom, the actual maps created for this voyage were not actually included in the report I had found. So they were found in a separate large format portfolio that wasn't digitally available. So I did some more digging, and I found that UCSB had these companion maps in their special collections. And I went down to look at them in person, and they were just beautiful. So here you can see the index map of all the individual maps. So in total, there were 68 large format maps, and they're indicated in these squares. Each individual square is a map that was created. And here's what two of them that you can see. Each map charts the presence of kelp groves for a particular area. From California, or from actually Baja all the way through Washington and then up into Alaska. And you can see here is the Santa Barbara Channel on the mainland side, from Gaviota in the west all the way to Ventura in the east, and then 3 of the 4 northern Channel Islands, Santa Rosa, Santa Cruz, and Anacapa. And I was so excited to see these maps in person. And I went through all of them and took pictures. I was like, they were beautiful and just kind of the places and things I love. And if we zoom in here on the lower part, you can see one of these maps, see the legend there in the bottom right, which gives a density of each kelp bed that is mapped. So these classifications range from very heavy to very light. And in this map, only thin and medium density beds were recorded here at Santa Rosa and Santa Cruz. And here you can see another map, which is the westernmost northern Channel Island, San Miguel. And here there's actually 4 different densities represented, from thin to medium to heavy and very heavy in the different colors. And here's a zoomed out look at that same map on the left with San Miguel and Point Conception, and then Catalina and San Clemente Islands on the right, just to give you a sense of how beautiful and comprehensive these maps are. And while the US government produced numerous marine maps, both before and after these specific maps were produced, we have not been able to find any that give both the location and density of kelp forests as they did in these maps.
Courtney, we got asked for a reminder of why the kelp was of interest, and that was because of the potash or potash, as you said, which was used. I didn't know it was used for ammunition, but also used for fertilizer. Yeah, and everything to make. I think the priority was fertilizer for this mapping, but also ammunitions. And this was in 1912, and almost the only source of potash back then was from Germany, from mining in Germany, and the U.S. really wanted to have its own domestic source to be able to increase crop production, especially around then. So that's why they spent, must have been, a lot of resources on this sailing voyage to map every single kelp bed. So it's pretty neat, and the fact that there's this companion report with the maps, there's so much information in the report too that is really interesting. It's sort of just like a logbook plus all the calculations that they did to be able to calculate how much actual potash they would be able to get out from each individual kelp bed if they were to harvest it. So we were, while we were really excited to find these maps that could give us an idea for our purposes of how the ecosystem looked historically in California, at this point, when we had found the maps, they were only paper maps in the library. So they weren't, there were no digital versions available. And so when we talked to John, we tried to, be able to get a digital version of our own. And then COVID also hit, so we couldn't actually do the scanning of these ourselves. But John discovered that Oregon State had some scanned versions of these maps that were not publicly available, and he was able to get us the files. And then we brought Nisha on to spearhead the process of turning these maps into spatial data that we could use to calculate how kelp beds have changed through time in California. So Nisha's going to tell you a little bit more about the process we use to digitize and georeference these kelp bed records to make them into data we could use.
Okay, hi everyone. Can you hear me all right?
Yep.
Yeah, great. Okay. Perfect.
Cool. Perfect.
Yes, sound great.
So like Courtney said on the previous slide, a major goal is to represent and translate these scanned paper maps into a digital format that we can actually use in a geodatabase, allowing for both data storage and data processing in the future. So later on in the presentation, Courtney's going to talk about some of the different ways we're using this data or planning on using this data for spatial temporal analyses and such. And my role in this project is really creating this digital data that can be used in the future. So the first step is georeferencing all of these individual paper maps to ensure that they are in the proper location and referring to the proper scale. And then we're actually going to digitize these kelp forests. Okay, so georeferencing, just a quick overview, is the process of assigning a real world coordinate system to a map or an aerial image. So when you import an image into ArcGIS Pro, it just kind of plops it somewhere. The program has no idea what the map is supposed to represent. and no idea where on the globe it's supposed to go. So you have to go in and physically assign a coordinate system to that image. And what this does is it physically moves this image to the proper location and it gives it the proper scale. So looking at the images on the slide, you can see that the map on the left hasn't been georeferenced at all. It's just in the middle of the Pacific Ocean. And after georeferencing it, you can see that it's supposed to be on the coast of San Luis Obispo. So the two maps on the right are properly georeferenced, and you can see that the coastlines that are drawn in match up with the coastline on the base map. Okay, so getting into this slide and how to actually georeference certain images, what's really handy about these maps is they already give you coordinates and they already have a coordinate system that you can work off of. So as you can see on the map image on the right, there's already a grid drawn in from when people drew the paper map by hand, and each of the four corners of the map have a coordinate pair, a latitude, longitude pair assigned to it. So you can navigate to the top left corner that's shown by the image on the bottom left on the slide. And essentially you click on a pixel that's on the cross of that latitude line and the longitude line, and you assign this latitude and longitude coordinate to this. And what it will do is it will move the entire image so that the pixel that you clicked on locks in at the location that you sent it to. So you're going to go ahead and do this for the other three corners in a clockwise fashion, and you should have a properly georeferenced image. Everything matches up. So in our example, this is a map of Slough. If it's of Slough, it's going to line up on top of Slough and the coastlines are going to match up. So once you're done, you're going to go ahead and export a table of your 4 georeferenced control points as shown in the bottom right picture over there. Now, this is really, really helpful because it allows anyone to georeference the map or image in the same exact way as you did. Essentially, if someone imports this image into ArcGIS Pro again, they can also import this control point table, and the program will automatically take these points and georeference the image, moving it to the same precise location with the same precise scale. Okay, next slide. Okay, so moving on to the digitization portion of the project. Digitization is the process of converting geographic data from a hard copy or scanned image into vector data. So looking at the bottom 2 images, the bottom left is a snippet of the map and some kelp forests before digitization. And the bottom right image is the same snippet after digitizing these polygons. So you can now see that these digital polygon kind of kelp forests. In order to digitize, you physically trace the polygon border, and there are many ways that you can do this. But in this case, my preferred method is what you see in the top right picture of the slide, where you trace it using polylines. Okay, so in this slide, there are actually 3 separate snippets. This is all off the coast of Alaska, and I just really included this because it shows how visually intricate and complex that these digitized kelp forests can really be. It's pretty visually pleasing, and you can kind of see all of the different colors and all the different types of densities of the kelp forests in Alaska. Okay, so now once you've created a digital polygon, you can attach data or attributes that describe the polygon. For example, the field survey sheet is the number associated with the map that you are digitizing. Courtney talked in the past few slides about kelp density earlier. So the polygon that's highlighted in the snippet on the right that we're attaching these attributes to, it is medium density, hence why it's a red color over there. And after digitizing and attaching attributes to all the kelp forest polygons in an individual map, you're going to export this map as a shapefile to be stitched together into a comprehensive database. And in the following slides, I'll show you a few snippets of our comprehensive California kelp geodatabase. So in this slide, you can see that the kelp kind of follows along the coast from Northern California, and it also details kind of kelp following Central California. I've zoomed in just a few snippets of the map, and you can see, as Courtney was explaining over there, San Miguel and Santa Rosa and all the different types of kelp density and biodiversity around these Northern Channel Islands as well.
Thanks, Nisha. And then, so, we had all the data associated with the maps. And then one additional cool and interesting piece of data came from the actual written reports that accompany these maps. And so here you can see in the yellow that the densities identified for each of these kelp beds, you can see how they relate to one another. So what they did, the surveyors actually went and cut samples from each kelp bed that they surveyed and measured the weight of the kelp captured in pounds. So these values can then allow us to better compare what those kelp densities meant in relationship to one another, and also better be able to compare these data to more recent surveys, because we know when they say medium density, what that actually amounts to in kelp.
And those those are 3 species, right, Courtney?
Yes, sorry, and yep, on top, Nereocystis is bull kelp. It's the big kelp with the big bulbous floats, and then the stipes come up. Macrocystis is giant kelp, which you see the most around Southern California, and then Alaria is a smaller kelp. And then there were also mixed beds that were recorded throughout, and they indicate which, for each individual bed, which species was included in that kelp bed. So there's a lot of information, which is pretty neat. So finding these maps, scanning them, digitizing, georeferencing them, associating the data, all of this allowed us to turn this information into spatial data that we can use to help complete our puzzle and tell the fuller story of how California's marine systems has changed through time. So currently we're in the process of comparing the kelp coverage represented in these historic maps with annual aerial kelp surveys that have been conducted by the California Department of Fish and Wildlife since 1989. So here you can see an aerial image of San Simeon Point taken in 2008, and then the corresponding 1912 map with kelp coverage at San Simeon Point. And our preliminary results show a really dramatic decrease in overall kelp coverage in Southern California. So here, Southern California is second from the right, but less of a loss in Central and Northern California throughout this time period. So from 1912 to 2016. But these results are really preliminary, and so this is probably for another presentation, but we are using these data to compare to current information, which is kind of the first time this has ever been able to been done for California. So what can be done with this data going forward? So we think that more in-depth spatial and temporal analysis can be done in California to see how things have changed, how kelp beds have changed through time and through space. And we would like to be able to discover also what happened in California between 1912 and 1989. So there's a big gap there. So we'd like to be able to combine these data that we have with smaller scale data from subregions to be able to track change through time kind of in more detail, and also discover more historical area information. And, hopefully similar analyses can be done to look at change through time in Northern Baja and Oregon and Washington and Alaska, because we have those maps now, and we just need the more recent data to be able to compare across time periods. And from a broader perspective, we'd like to enlist as many people as are interested in maps to help us discover more historical maps that can give us more insight into the past. So one type of data that's really, really sparse in ecology is historical habitat coverage and abundance estimates. And that's not just for kelp forests, but basically for kind of every habitat type that exists on the planet. There's a real lack of historic information. So if anybody here knows of historical maps that might be out there that could help us better understand what ecosystems look like in the past, we'd really love to discover more of these far as kelp goes, any of these maps might just be hanging on someone's wall. And as far as kelp goes, I've only seen one other example of historic kelp maps being discovered and used to try and see what the ecosystem used to look like. And the only one I know of was in British Columbia last year. A geography professor walked into her colleague's office and realized that the squiggly lines on this map might have been a distribution of kelp. So this is just an example of somebody walking into an office and kind of making that connection with an old map. And if there's more, it would be great to just have more of that, kind of seeing what maps are out there and how they can be used to sort of tell us more about the past. I think these can not only help us better understand what existed in the past, but also, make sure that we can save these records before they're lost forever. So another important thing that we're going to do, and we think, is important to do, is saving the historical records and making sure they're preserved into the future and shared with the broader community. So digitizing and georeferencing these maps and then sharing them in data repositories so that they're preserved, and then other people can use these data for lots of other purposes. So we plan to share these metadata in the Knowledge Network for Biocomplexity, or KNB, and it's a data repository that is an international data repository, and it's intended to facilitate ecological and environmental research. But there are a ton of data repositories with specific geographic focuses or fields of focus, and where you can store 100-plus-year-old data like this, and hopefully it can live on for many, many hundreds of more years and be shared with many more people. And lastly, I hope that we can all, that next we can all sort of learn more about the history of the places that we care about through projects like this. And so with that, I'll leave you with plate 4 here from that 1915 potash report. In every image that the author was required to do a measurement for, he used this small ruler that says "Study Nature, Not Books" on it, which I think is kind of a hilarious, 115-year-old nudge or dig at all of us. So thanks so much for having us, and thanks for inviting us to this. This has been really wonderful.
Yay, I'm seeing applause on the video wall. I think I interrupted you with one question from the chat, but I'm going to take kind of the moderator's privilege and ask you the first question myself. Will you remind me, like, how long were they out? Like, was it a 2-year voyage? I mean, not continuously at sea, but the process took.
It was, yeah, and I think the Alaska voyage was a separate voyage. Okay. But the West Coast was over the course of at least a year. And I think they actually went 2 seasons through to map all of this. Yeah.
Yeah. Federal scientists at work. Thank you for paying your taxes, everybody.
Yeah.
So feel free to unmute yourself. Someone points out that there's a lot of, in Alaska, there's a lot of people being very creative with kelp products, pickles, salsa, etc. And actually, there's I think pickled kelp is starting to become like a hipster trope in Seattle. All the fine dining establishments are now starting to serve pickled kelp.
Sounds good to me.
Yeah. Jonathan raised his hand. I think Jonathan Van Coops, did you have a question?
Well, yes, I just had a comment. I actually worked for the Coastal Commission here in California for, gosh, almost 40 years. I'm retired now, but we did a lot of mapping and found out about a lot of mapping that the federal government had done all the way back to the national, the old Coast Survey days, where they had 1 to 10,000 scale maps showing kelp beds and other resource boundaries, quite detailed with survey reports. And some of this information has been digitized and georeferenced, but others remain to be done. And you should probably find out as much as you can about these other efforts that have been done, because I know at our coastal commission, we did a lot of digitizing of wetland boundaries and other things that characterize these historical resource extents, and they would be very useful.
Yeah,
Yeah.
we are actually using the all the wetlands data. Those are really cool maps. They're like a T-sheet project, and we've been using all those data to map the coastline, so wetlands and estuaries and sand dunes. But the actual offshore kelp beds have been kind of problematic for any historic information. But it's, yeah, that T-sheet project, those have been really, really useful for us too.
And the Coastal Commission, there's actually several of them, I believe. The local one here from Santa Barbara, I don't know if it will, if it's actually physically in Santa Barbara, but we have their older.
Ventura.
It's in Ventura. We have some chunk of their records that didn't go to NARA, that didn't go to the National Archives. So that's one of the things we try and do locally, is if, so there would be maybe nautical charts, like just plain old navigation charts that might have, you know, someone's survey work that never got published, or it got published in some other format, but it's that chart with people like Jonathan's, you know, labor drawn on it, literally with pen and pencil. Sometimes that information is equally important, and there's all sorts of projects. A lot of times when a researcher like Courtney finds a map, it inspires a project. Courtney was already working on the kelp.
Yeah, even old agencies, the Department of Navigation and Ocean Development existed before the Coastal Commission, and that's where I became aware of this 1912 kelp surveys that have been done. And you're absolutely right. There were a lot of special projects that staff members took these old maps and drew them onto other maps for specific purposes, and now some of those still exist and could be digitized and real information extracted. There's a lot of valuable work that was done that's not yet really captured for the kind of effort that we've just seen described, which is really nice. This is a great presentation, as was the other one too, by the way, as I'm commenting.
John, could I ask Courtney a question? It's Ron.
You bet. You bet.
Yeah.
Courtney, so I put this in the chat. A wonderful presentation. Whatever happens to all that kelp that we see washed up on California beaches?
Yes. So that actually, there's a whole beach ecosystem of animals that use that kelp, either for food sources or, so it kind of breaks down into the beach, into the sand, and is used by a ton of different, like if you actually go out to a beach and look at a really active beach where kelp has washed up, within a few days, that kelp will have completely disappeared just from other organisms using it. There's actually there's a scientist at UCSB named Jenny Dugan who studies kind of beach, just sort of what happens to kelp on beaches. And she has some really cool research that looks at all of that.
Fascinating. Thank you.
Yeah, thanks.
I would love to ask a question to the presenters. It looked like at one point you were showing false color infrared imagery that maybe was being used to assess the current situation with kelp beds. Is there any work in advancing those sort of methodologies?
There is. There's been actually also at UCSB a ton of work. So California Department of Fish and Wildlife uses those aerial image surveys that we showed you. But there's been a lot of work at UCSB using satellite imagery to map kelp beds. And that can actually give like more seasonal change through time, because kelp beds actually do change quite a bit throughout the year. And they can, I think that, you know, they can have multiple time sets within a year to look at kelp that way. And that work, a lot of work is done by this guy, Tom Bell. And they're currently working on kind of expanding that research to be able to look more through seasonal time and space with satellite imagery.
Nice.
So can you give us some idea of like what that seasonal variation is? Is it like a leaf on, leaf off kind of tree situation, or?
It's actually really driven by storms. So the winter swells will come through, and you know, if there's a big swell year, you will lose a lot of kelp in the winter from those swells. And then there's also kind of a warm threshold. So climate change has been affecting kelp quite a bit because there's this, you know, there's a higher warm threshold. And some theory is that there's these rhizoans, these encrusting organisms that when it's warmer can encrust on the kelp more and sort of hinder kelp growth in warm times. And then in the cold times is when the winter storms come through and can kind of bring all the kelp, like cut down all the kelp in one kelp bed pretty quickly. But I see a question here too, how quickly they can grow back. Some kelp can grow, macrocystis, the giant kelp, can grow 18 inches a day in some places. So it can come back pretty quickly once it is. So if there is still harvesting kelp going on here, but you know, if you harvest, they just cut the tops of the kelp off to harvest kelp, and it can regrow pretty quickly.
I have a question. How far offshore do these kelp beds begin, and how far out do they go? And what's the maximum depth that they are, that you might see them?
Yes, so they are photosynthetic, so they need light to be able to live. So it depends both on kind of how clear the water is, and so the light can get to it, and then what substrate is down there, because they need rocky reef to actually grow from, so they can't really live in sand. So in terms of light limitation and all of that, the deepest macrocystis probably goes down to 200 feet, would be kind of the deepest probably you would find these big kelp. And here in California, we have a pretty steep slope. So it doesn't actually go that far offshore because of the steep slope and the light limitations. Yeah, so 200 feet is kind of their max, I think.
Thank you.
Courtney, how do you think about the challenges of kelp? I don't know if I can call it deforestation. How do you compare that challenge with other challenges that the ocean in general faces?
That is a good question. So I guess it's kind of a multi-part question, but for instance, you know, a lot of kelp, you know, kelp is a foundational habitat. So it not only provides kind of like housing and coverage for species, it also provides food. So in Northern California right now, we've had a huge die-off of kelp, kind of like the biggest die-off of kelp we've ever seen in the history of information that we have. And it's been sort of this perfect storm of really warm water temperatures, plus sea urchins eat kelp, and there has been a huge increase in sea urchins in the northern part. And so up north, there's hardly any kelp. And what that has meant is that all the species that rely on it are kind of crashing. So abalone is, you know, a pretty key ecosystem component of California. And, you know, so let's say humans arrived here 13,000 years ago, and we're even then harvesting abalone. And we have been harvesting abalone throughout history. And they closed the commercial fishery for abalone in California in the 90s because they were crashing. And with this last die-off of kelp in the north, 3 years ago, they closed the last recreational abalone fishery in California. So, you know, this is kind of the first time in human history in California that abalone are not being harvested. So in 13,000 years, like this is the first time ever. And it's because kelp are so foundational to the ecosystem that, you know, once kelp is doing poorly, all the species around it start to do poorly. So in Northern California, it's been a huge challenge. And I would say when you talk to people in that area, it's definitely the biggest issue facing the ocean, because all the dive industry that relied on it is now gone. All the restaurants and hotels that people would come for the summer to go abalone harvesting are now gone. Like a ton of a ton of the economy has shut down in these old dive towns up north. So for Northern California, I'd say it's kind of the #1 thing that people are thinking about and trying to manage and figure out how to recover kelp. In Southern California, I think it's a little bit, while Southern California has lost the most historically, it's kind of come back, and I think people are thinking less about it being a huge issue. And that's partially also because in Southern California, we have other species below point conception that eat urchins. So urchins are kind of like mowing down kelp forests. And so where there's a lot of urchins, there's not a lot of kelp. And north of point conception, we don't have sheephead fish that eat urchins, and we don't have lobster that eat urchins. So north of point conception, when you take out otters from the ecosystem, you kind of lose all the urchin predators. But south of point conception, when you take out otters, you still have sheephead and you still have lobster. So there's kind of this a way that we can manage urchins a bit better in Southern California naturally through other predators. But in Northern California, once you lose the predator, the otter, kind of everything does more poorly. So Southern California is doing a bit better.
Thank you. Thank you. I just have one quick follow-up. Is it, I mean, or maybe you addressed this already. Can kelp can kelp be reforested? Can we, like, you can replant a?
There's a lot of work to try and figure out what to do about how you can increase kelp right now. So I think actually there were some California Sea grants given this year to try and figure out what we can do. Like if you can seed kelp beds to recover them, and there's been some work on that, or if we need to do more of like getting rid of their predators, or kind of what we can do, because it is becoming such a dire thing in California in the last few years.
Thank you.
Well, it sounds like we should eat more urchin.
Yeah, eat more urchins, eat more uni. Yeah, that's one way.
Does anyone want one last question from Nisha or from Courtney? 4, I should say.
Well, what's next with your project? Can you say again where this is all headed?
Yeah, so we are, this kelp piece is just one piece of this broader project, kind of looking at how humans and ecosystem have changed in California for all of history. So we're working on putting a paper together that includes this information plus other species of interest. Like we mentioned, the estuaries and those old maps from the estuaries that have already been digitized and georeferenced, and abalone, and we're kind of putting together a big paper and some materials on that whole history through the lens of estuaries, nearshore kelp forests, and then the offshore systems, so that we can kind of get all that information in one place and share it. And I should say this work is also with the, so we're both at UCSB, but we've been working with the Nature Conservancy. So TNC in California has been kind of spearheading this too with us.
John, you're muted.
Well, thank you so much, Courtney and Nisha over there. And I'm seeing applause, notes in the chat.